Hello students, welcome back to chemistry class. In the previous class, we were discussed on how to balance a chemical equation and what are the characteristics of chemical reaction. In today's topic, we are mainly going to cover the types of reaction. Here we have 5 types of chemical reactions. They are combination reaction, decomposition reaction, single displacement reaction, double displacement reaction, and finally redox reaction. In today's class, we are mainly going to discuss the first 4 types of reactions. Let's discuss the first type of reaction, that is combination reaction. So what is combination reaction? Combination reaction is nothing but it is a type of reaction in which 2 or more reactants combines to form a single product. So A plus B gives AB. This type of reaction is known as combination reaction, which means that 2 or more reactants combines to form the product only 1. Okay, so when you write the example, hydrogen reacts with oxygen to form water, H2O. Is it balanced? No. Here 2 oxygen, here 1 oxygen. So multiply with 2. Here 4 hydrogen, here 2 hydrogen. Again multiply with 2 here. This is one of the example of a combination reaction because 2 reactants combines to form a single product. The product is single. Okay. So let's have some other example. So what happens when magnesium combines with oxygen? So the magnesium combines with oxygen, definitely you will get magnesium oxide. So the magnesium oxide symbol is MgO. The valency of magnesium is 2, valency of oxygen also 2. Both are cancelled. So the final chemical formula is MgO. Is it balanced? No. 2 oxygen, here 1 oxygen. So multiply with 2. Here it is 1 magnesium, so multiply with 2. So this is also another example of a combination reaction. Because 2 reactants combines to form a single product. This is also A plus B gives AB type reaction. Do you have any other example? Yes. Carbon plus oxygen will give you carbon dioxide, CO2. So 2 reactants combines to form single product. So this type of reaction is called a combination reaction. Let's define the combination reaction in terms of an exothermic reaction. So the same combination reactions can be expressed. What happens when calcium oxide combines with water? So calcium oxide is known as quicklime. The calcium oxide is known as quicklime, which is used for whitewashing. To this calcium oxide, if you add water, you will get calcium hydroxide, CaOH twice. This calcium hydroxide is known as slaked lime. The name of calcium hydroxide is slaked lime. So this slaked lime is produced along with, you can see, a tremendous amount of heat energy is produced. So look at here children, when you add water into the quicklime, you got slaked lime. This slaked lime is used for whitewashing. The slaked lime is used for whitewashing. And look at this equation children. During this time there is large amount of heat energy is produced. So this reaction is one of the example of combination reaction, and this reaction can be exothermic reaction. This reaction is also known as exothermic reaction. Why this reaction is known as exothermic? Because during the reaction, what happens? Large amount of heat energy is produced. As a result, this reaction can be exothermic. Okay. The second type of equation is the decomposition reaction. Okay. The decomposition reaction is just opposite to combination reaction. Note the point. This is just opposite to combination reaction. Why it is opposite to combination reaction? Because in a combination reaction you will learn that two or more reactants combines to form a single product. But here what happens? A single compound breaks down to form two or more products. That is the difference between combination reaction and a decomposition reaction. So generally you can write a larger compound AB breaks down to form A and B. This type of reaction is known as decomposition reaction. Okay, let's have some example. So what happens? Calcium carbonate undergo heating. So when you heat calcium carbonate, you will get calcium oxide and carbon dioxide gas. Look at here, children. This is only a single reactant. A single reactants undergo decomposition in the presence of heat. So that time two reactants are formed. This is calcium oxide and this is carbon dioxide. Okay, so this type of decomposition is known as thermal decomposition. This type of decomposition is called thermal decomposition because with the presence of heat, these compounds undergo decomposition. So this decomposition is known as thermal decomposition. Okay, this is a first type of decomposition, that is thermal decomposition. Okay, this is just opposite to the combination. Here the reactant is single. You can see more than one or two products. Okay, now let's have another example. The same water. Take water and pass electricity. Take water and pass electricity. So what happens? This water breaks down and converted to hydrogen and oxygen. Hydrogen and oxygen, it is balanced. Okay, in the combination reaction, you have learned H2 plus O2 gives H2O. But in the case of decomposition reaction, a water is again decomposes to form hydrogen and oxygen. So here we are using electricity to decompose this water. So this decomposition reaction is known as electrolysis. So this decomposition is known as electrolysis. Electrolysis of water, you will get hydrogen and oxygen gas back. This is an example for electrolysis or electrolytic decomposition. Okay, now let's have another example for decomposition. If you have silver chloride, in the presence of sunlight, this compound undergo decomposition and the silver chloride is converted to silver and chlorine gas. So here the balancing 2 chlorine, 1 chlorine. It is 2, 2. So look at here, children. Here what happens? In the presence of sunlight, a single reactant is converted to silver and chlorine. You know what type of decomposition it is? This is a third type of decomposition. This reaction is known as photolysis. Photolysis or thermal decomposition. Photochemical decomposition. Photochemical decomposition. Because in the presence of sunlight, photon means sunlight. So in the presence of sunlight, the single reactant undergo decomposition and it converted to two similar products. So this is another example of a decomposition reaction. Children, this reaction have an application. You know where is the application of this reaction? This reaction is mainly used in black and white photography. This reaction is mainly used in black and white photography. Why it is used in black and white photography? Because this undergo decomposition and a grey colored silver is formed. So as a result, this is used in the black and white photography. Nowadays, we know that everything is in the SD card, right? So this is one of the application of a decomposition reaction. The third type of reaction is a single displacement reaction. So this is a type of reaction in which the highly reactive element displaces the least reactive element from a metal salt solution. So that is the definition for single displacement reaction. So children, let's understand this by the general formula. A plus BC gives AC plus B. Okay, here you can see A is a metal, B is the metal. Here BC is a metal salt solution. It is a metal salt, a salt containing metal and non-metal. This is a metal, this is a non-metal. Okay, so from this metal salt, B is isolated, B is separated. In the place of B, the highly reactive A has come and a compound AC is produced and B is separated. Here A is highly reactive than B, so that B is displaced. So how will you come to know which element is highly reactive, which element is least reactive? So that children, you can see a reactivity series. So reactivity series is the arrangement of elements in the decreasing order of their reactivity. So on the top of the reactivity series, you can see that the most reactive elements. When you come down, you can see the reactivity decreases. So this reactivity series you should by heart it. This is arranged based on the reactivity towards different components. Reactivity towards oxygen, reactivity towards acids, etc. So after analyzing, they have generated this reactivity series. So potassium is highly reactive. You know that. Sodium also highly reactive. When you keep it in an open condition, it will blast, right? So potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver and gold. I will teach you a song. Poso, Kalmak, Aluzi, Aile, Haiko, Merzigo. So study such a way that it will be by heart. Okay. So here I am going to ask you a question. What happens to an iron nail when it dipped into copper sulfate solution? What happens? So let me write the equation. Iron nail is dipped into copper sulfate salt solution. So what is the product obtained? Will it undergo displacement reaction? Look at here, this is a single displacement reaction because A plus BC type reaction. A is a metal, B is a metal. Now let's understand whether it will replace copper. Look at the position of iron. Look at the position of copper. So copper is least reactive than iron because copper is placed below the iron. So copper is placed below the iron, so copper can be easily removed, easily separated or easily displaced. In the place of copper, iron will come because iron is more reactive than copper. So how will you write? You can write FeSO4 plus. Who is separated? Copper is separated because copper is least reactive. Okay. So what is the color of copper sulfate? This copper sulfate is known as blue vitriol. The color of this solution is blue. When you reach here, you can see the color of the solution turns to green due to the displacement reaction. On the iron nail, you can see that a reddish brown deposit of copper is there. So, okay, the blue colored solution turns to green color because of the displacement reaction. Now, the second question, if copper reacts with iron sulfate. Will it undergo displacement reaction? No. Why? Here copper is least reactive than iron. Here copper is here, iron is here. So this copper is not capable to replace iron. So this is least reactive. So which will not undergo any reaction. So no reaction will be taking place. Okay. So this type of reaction is called the single displacement reaction. Okay students, the next type of reaction is the double displacement reaction. So double displacement reaction is the type of reaction in which here the exchange of two ions taking place. Exchange of ions taking place during the reaction. So this double displacement reaction is also known as precipitation reaction. Double displacement reaction is also known as precipitation reaction. Okay. Generally, you can represent the double displacement reaction like AB plus CD gives AD plus CD. So this type of reaction is called a double displacement reaction. So we know that A plus B minus. This is the cation, this is the anion. C plus D minus. This is the cation, this is the anion. So when you exchange these cations and anions, means how will you exchange? You will get A plus D minus plus C plus B minus. Okay, so this sort of exchange is taking place during the reaction. So this type of reaction is displacement reaction. Let's have one example. So what happens to barium chloride, BaCl2? Barium valence is 2, chlorine valence is 1. So barium chloride plus sodium sulfate. Sodium sulfate means Na2SO4. The valency of sulfate is 2, it is given to sodium. The valency of sodium is 1, which is given to sulfate. So how the exchange of this ion taking place? So here you can see Ba2 plus and Cl minus. Here Na plus and SO4 2 minus. How the exchange of ion taking place? Here barium and sulfate. How barium sulfate is formed? BaSO4. Valency of barium is 2, valency of sulfate is 2. Both should be cancelled. So finally it is BaSO4 plus. Next it is sodium and chlorine. So sodium chloride is NaCl. Both have valency 1. So NaCl. Is it balanced? No. Here it is 2 chlorine. Here it is 2 sodium. Here it is 1 chlorine and 1 sodium. So multiply with 2. Now it is balanced. So look at here children. This type of reaction is double displacement reaction. Here both the ions, both cations and anions get exchanged. And this salt is insoluble in water. So that is why it is called a precipitate. This is the precipitate. That is why the double displacement reaction is also known as precipitation reaction, because an insoluble salt is formed. An insoluble salt, barium sulfate, is formed. So that is the precipitate. So this reaction is also known as precipitation reaction. Now let's have another example that I have shown you in the last class, like lead nitrate, PbNO3 twice. Lead nitrate combines with potassium iodide, Ki. So what is the product? Exchange the ions. Lead iodide, how will you write? PbI2, because valency of lead is 2, which is given to iodine. Valency of iodine is 1, which is given to lead. So PbI2 plus potassium nitrate. How will you write potassium nitrate? Potassium is K, nitrate is NO3. Okay, is it balanced? Is it balanced? No, 2 iodine. So when you make it 2 here, it becomes 2 potassium. So here it is 1 potassium, make it 2. So here also insoluble salt is produced, that is called a precipitate. Precipitate can be written in short way, PPT. So this is the precipitate. The color of the precipitate is yellow because the color of the potassium iodide is yellow, so that it precipitated as yellow in color. So the precipitate is lead iodide. So these 2 reactions were there in your syllabus. Here the color of the precipitate is white. Here the color of this precipitate is white. Here the color of this precipitate is yellow. Okay? Let me ask you a question. In this case, is it necessary to use a reactivity series? No. Because reactivity series is only we are using in the case of single displacement reaction. But here we are going to exchange both cations and anions. Then only it will form the products. So this type of reaction is called a double displacement reaction. Okay.